So this short video is going to introduce you to a concept known as dimensional analysis, sometimes referred to this as the factor-lable method. And this is a good start to doing some calculations. When we get into the quantitative side of this course, you're going to be responsible for quite a few different types of calculations. But there's a similarity to almost all of them, and that is that you're going to be converting between different quantities, and to do that you need things that are known as conversion factors, and you're also going to have to keep track of your units and divide out units correctly. And so this video introduces you to both of these concepts, but not in the chemical context. This is more in some everyday calculations, things that you might be familiar with. So we might as well get started. Start with a few simple questions. I'm pretty sure you know the answers to most of these things. I think you all realize there are 60 seconds in a minute. I'm sure a lot of you do also realize that there are 10 millimeters in 1 centimeter. Again, I'm pretty sure most of you know that there are 12 eggs per dozen. But you may not know how many minutes there are in a millennium. Why wouldn't you know that particular relationship? Well, it's not a very common one. It's not something we use regularly. We very regularly use this concept of a dozen being equal to 12. The SI system is based on base 10 units, so 10 millimeters in 1 centimeter, etc. But minutes in a millennium is not something very straightforward. But we could calculate that. We could find it. And I actually did calculate that earlier. And there are, in fact, 5.3 times 10 to the 8th minutes in 1,000 years. So not a common one, but we can figure it out. How many centimeters in a mile? Well, again, this isn't commonly known. It's not something we do regularly, but we could find out if we wanted to. It's not really that hard. So this is sort of what we're looking at in this video. We're going to look at some of these relationships and how to use them. Now, one thing I will mention about watching videos, occasionally you might want to pause it. This might be a good time to pause the video, have a read of all of this text on the page, and then restart the video and hear what I have to say about it. So again, if you're going to pause and read, you might want to do that now. So conversion factors are a pretty central theme to a lot of the calculations we do. And basically what a conversion factor is it's something made from two terms that describe the same or equivalent amount. And so it ends up being a fraction. So a conversion factor is just a fraction made up of these equivalent amounts, one over the other. And so in essence we are multiplying by 1, even though it doesn't look like that. But we're not changing the amount, we're just changing the unit. So here's a conversion factor. 1 inch is equal to 2.54 centimeters. And so these are equivalent amounts. If we were to measure an inch, it might be roughly that, but if we measured it exactly, we would measure that as 1 inch, and that would be exactly the same as 2.54 centimeters. So the units are different, but the amount is identical or the same. So if we have a conversion factor, we can set up these fractions, and these fractions then relate these two equivalent amounts. So there's one conversion factor, 1 inch divided by 2.54 centimeters. And so the other one is just the reciprocal of that, 2.54 centimeters per 1 inch. So two conversion factors come out of the same relationship. Well, we can do the same thing for the relationship between kilometers and miles. 1 kilometer per 0.6214 miles, or 0.6214 miles per 1 kilometer. So conversion factors. You should be able to come up with two conversion factors for any relationship, and your job then becomes using the right conversion factor. And we'll see how that works in a minute. So it's really important, it's actually imperative that you include units with conversion factors, because that's how you're going to keep track of things. The other thing I want to mention here is that most conversion factors have been determined to a pretty high level of precision. If you look at this relationship, 1 centimeter per 0.393700 inches. That's a lot of precision. And so this conversion factor would not be the number that sets your significant digits in an answer. The other thing is, a lot of these relationships are absolute relationships. So 12 eggs, or 12 is 1 dozen. If you have 11 of something, you don't have a dozen, so you wouldn't use that conversion factor. If you have 49 seconds, then you do not use the relationship 1 minute equals 60 seconds. So these absolute relationships also do not set significant digits, because absolute relationships have an infinite number of significant digits. So the take-home message here is that the number used in a conversion factor will not determine sig figs in your final answer. That's very important. So you pretty well always go to your question and a value given in your question to set the number of sig figs. So I do have an expectation when you present these. It's not a huge expectation, but it's an expectation nonetheless. You're going to write a fairly simple equation, and that equation starts with what it is you're looking for. You're going to have an equal sign, and you're going to write down what you're given and multiply that by a conversion factor. Always include units, I've already mentioned that. And always report your number with the correct number of significant digits. So now we can try a few problems. So let's look at this one. So this relationship between centimeters and inches. Well, I want to find out how many inches there are in 11.7 centimeters. So here's my equation. What am I looking for? Inches equals the value I'm starting with or given, my 11.7 centimeters. I'm going to multiply by a conversion factor, and that conversion factor is a fraction, and I want to end up with inches, so my inches part of the relationship is going to be in the numerator, and in my denominator is my 1 centimeter. And you'll notice that unit centimeters divides out. And so what does that equal? Well, let's plug it into the calculator and see. And so you can see I get this great big number in my calculator. And so I can write that down if I want. And so I'm going to write down 4.606 6062900 inches. But if I look at my question, the value that's given is only 3 sig figs. So I can't write a number with, 8 sig figs. So I'm going to round, and this is the number I used to round because I want it to be 4 sig figs. So my answer is 4.61 inches. So first question done. Now, let's look at this one. So a relationship between miles and kilometers. So how long is a marathon measured in miles if we want to look at it in kilometers? So again, what we're looking for is kilometers. 26.22 miles times my conversion factor. Well, my conversion factor in this case is going to be 1 kilometer divided by 0.6214 miles. And what do I get when I do that? Well, again, you can see I have this great big number, and I'm not going to write down that great big number because I know I don't have that level of precision. I only have 4 sig figs given. So my answer will have 4 sig figs, so I'm going to round. So my answer becomes 42.20 kilometers. Now, the other thing you do to string along conversion factors And once again, you should be able to do this. Some of these relationships you already know. So we're looking for milligrams in a ton. Well, 2.2 ton. A metric ton equals 1,000 kilograms. So that's going to be what we multiply by first. We want to get rid of ton and get into kilograms. So that's 1,000 kilograms per 1 ton. Ton divide out times, well, 1,000 grams in 1 kilogram. Again, that's something you should know. Times, well, 1,000 milligrams in 1 gram. And again, that's something you should probably know. And so I can write this down as a great big unwieldy number, 2,000,000,000 milligrams. And that's, as I said, an unwieldy number. I want it to 2 sig figs, so I might as well write that in scientific notation. So 2.2 times 10 to the 9th milligrams. Well, the other thing you can do is, as I said, string together conversion factors you already know, but they may require 1 or 2 steps. And this one I'm going to do in 2 steps. You might want to try this one in a minute after you've seen how I go about it, or you can try it on your own. It doesn't really matter. But how many seconds have passed since you were born to the nearest day? So I'm going to do this in 2 steps. The first step is I'm going to convert from years to days. So I want to find days. And I just turned 50. So I have 50 years times 365 days per year. So years divide out. And I'm going to add to that how many days, because I just turned 50 about a month ago. So it's another 41 days. So when I do the math on that one, I end up getting 18,291 days. So I'm 18,291 days old, but I want it in seconds. So my next step is to convert from days into seconds. So what am I given? 18,291 days. And now I just string together conversion factors I know. So the first one would be, let's get hours. So that's 24 hours in 1 day. Multiplied by, well, 60 minutes per 1 hour. Well, 60 seconds per 1 minute. And so minutes divide out, hours divide out, days divide out. I'm left with a unit of second, which is what I want, seconds. And so when I plug that all into the calculator, I get this terrifyingly high number, 1.58 times 10 to the 9th seconds. So that's how many seconds I've been alive. It seems like a lot. I guess it is a lot, but so this last question I want to show you is demonstrates how sometimes you have to convert a couple of different units in the same question, and so this one takes care of that. So I have this 1988 Volkswagen that goes seemingly rapid rate of 24.4 meters per second. That's a pretty decent speed for this car, and so I want to convert that into miles per hour. So meters to miles, seconds to hours. So I have to convert 2 different things. So let's get started. So I'm looking for miles per hour, and it's going to equal what I'm given, 24.4 meters per second. And so let's take care of the distance first. So distance I want to get from meters to miles. So miles needs to be on top. And so I'll get to yards first, 1.094 yards per 1 meter times 1 mile per 1760 yards. And so in terms of those units, I'm left with the unit of mile, and that's what I'm after. So that's good. Now I have to get the time unit in the correct way. So I want to get seconds on the bottom. I want to end up with hours on the bottom. So I might as well get the minutes first. And so what I have is 60 seconds per 1 minute times 60 minutes per 1 hour. And when I look at my unit analysis here, seconds divide out, minutes divide out, and again I'm left with this unit, hours in the denominator, and that's what I want, miles per hour. And so when I put that in through the calculator, I get 56.4 miles per hour, which actually isn't that fast, but it is the correct answer to 3 sig figs, and that's the main thing. And so this little introduction to some calculations I think you'll find useful. It's really important that you keep track of your units, so write your units with your conversion factor, and you'll gain skill in identifying the correct conversion factor to use.